Good morning, good morning, good morning, good afternoon, good evening. You have reached Science Saturday Chats, and I am David Hilster, your host. And we got a lot of great topics today to talk about, so don't go away. Yes, sirree. We are the Saturday Science Chats sponsored by the John Chappell Natural Philosophy Society and Dissident Science. I'm always running because I get up in the morning and put this whole thing together for us every morning. We got a great topic today. You don't want to miss it. Science reality versus science poetry. We talk a lot of words, but what do they really mean? And I think that gets us into a lot of trouble. And I'll tell you, I certainly am one of those people who are a stickler on that because I'm a linguist, as many people know, so I worry about words all the time, and it's very important to me for us to get a handle on that. So I'm going to be going through today my introduction here and get this started. We're not going to have a whole lot of talk. We're going to have more about really our topic today, which is here it comes. So yeah, I am Dave DeHilser again, and we are here every morning, afternoon, and evening, and really late at night in Australia, if you happen to be in Perth. And we're here discussing all kinds of topics for critical thinkers, dissident scientists. And I want to welcome everybody from the John Chappell Natural Philosophy Society and also from Dissident Science Channel. We really hope these discussions are enjoyable to you. And today we're going to be talking about a lot of stuff, but let me go as normal through my introduction because a lot of people, this is their first introduction to what we do here. So let's take a look at our mission. Of course, is we are an organization that above all promotes critical thinking without malice, to be an organization that supports, publishes, and promotes serious work outside mainstream science. You're not going to see anything like this on YouTube. I mean, you're not going to see a group of people doing this on YouTube who support ideas outside of mainstream. Of course, we also provide a forum for open debate in modern topics such as physics, cosmology, philosophy, and mathematics. To provide a forum presenting serious papers and theories without fear of censorship, to be run and controlled in its entirety by its paid memberships, including the election of its directors by its members. That's very important. We learned that the hard way for sure. How to participate? Of course, you can sign up on our naturalphilosophy.org. Consider becoming a member. Really, really important. I appreciate people becoming members. We actually had a donation from a longtime member of the MPA and CNPS. I want to thank Mr. Crenshaw for that. He was a great speaker many years in the NPA, talking about special relativity especially. Really always enjoyed his talks, and I want to thank him very much for his membership and generous donation. It's really greatly appreciated. Again, all this stuff costs money, and we talk about that. Go back and look at our first of the year, and it turns out that we talk about what it takes to keep this going, and it's not ether or particles or lattice models. It's actually good old-fashioned currency, and that will help us pay our monthly and other dues, monthly and annual dues. So, oh my goodness, as I go here, look at this. My brother in arms in the dissident world. I really miss him a lot. Greg Volk, I do get to talk with him once in a while. It's great to see him here. Maybe he'll get in the green room Go to live.naturalphilosophy.org. Come on, Greg. But anyways, Greg is an amazing person. He's one of those people. I think I met him in 2008 now, man. It's 12 years. But we've been through so much. We did so much work on the database and on this group. And he's constantly, even though he's not with us, he's constantly looking to get support for this kind of work. And I mean big support, but he is truly very super knowledgeable about dissidence. Hopefully we can have him on. That's what I need to do. I need to get him back on here and just talk. But anyways, you're welcome, Greg, to come on by. Anyways, participate in the community discussions, of course, on our website, and post news and happenings on social media, because that is where it's happening. That is for sure. Our websites are community naturalphilosophy.org is there. It's a really great new website. We're paying for a really nice software for that. You should take advantage of it. There's really great discussions going on. People coming in. We get a lot of new people. If Greg, you're listening in, we're getting lots of new people from our website coming in and all the things we're doing from our social media. So it's really great. Of course, we have our online magazine, which are for those people who are not so technical. You can go there and read all about the great scientists that are working outside the mainstream, what they're doing, what are the problems in mainstream physics. You're going to see lots of papers, lots of articles about that. Pretty amazing. And of course, we have our Wikipedia, which has really our database was transferred. A lot of our database that Greg and I put together was transferred over to the Wikipedia. And of course, this year we're going to be putting together our first courses in natural philosophy and the John Chappell Natural Philosophy University, Chappell University course in natural philosophy. So just read it there. Play bumper. Already did that. Yeah, man, I edit these like frantically. I mean, that's why I was like 30 seconds late. That's not good today and age. But our community website, this is some of it. Just a couple days ago, you can see some really interesting discussions going on. Lots of new people. I think we're up to 60, almost 70 people now that are registered. So a brand new site. So that's pretty good. And these are active people. And this person actually brought up a video from Ron Hatch, who unfortunately passed away. It's sad. I mean, that guy is oh my gosh, he was actually an investor in my film way back. He was a great supporter of this organization. If you don't know about Ron Hatch, go to sciencewoke.org and read about him. But he had over 30 patents in GPS and was one of the brave people that said, relativity is not supported by GPS, even though that's what they teach around the world in all universities. Hey, don't go ask a guy who is a person who's interested in physics and relativity and has 30 patents in GPS. Don't go ask him about whether or not GPS supports relativity. No, go ask college professors who don't know anything about GPS and spout out how they believe it should work. Anyways, you can see there's lots of great discussions. So binary mechanics, that's a new group that was put together. We have consciousness, you can see there. Physics model. Where's my pointer? Laser pointer. There we go. So check out the groups. But this binary mechanics group is out there. So you can go in there, create your own group. And discuss things. We have one for our particle model. So you have your own theory or an own a topic you want to talk about. You can create it, and then other people can join in, and all that activity is shown on the feed. So you can see that very easily. Unfortunately, there's a really great, an email chain. What's an email chain? That's when you get kidnapped into a email discussion. Someone decides you need to hear everything they're talking about, and so does 15 to 20 other people. They just put all their emails together and they blast everybody, and then they just start discussing. That's not great for the people who don't want to be in it. I'm not saying I don't want to be in it, but also it's lost to the ether, pardon the pun, and that's really sad because there's a lot of great discussions go on, and people do it for themselves, and not for others. And that's too bad. And I think one of the problems is the discussion group itself can be like-minded people who will have no one challenging them. And what happens is that becomes a very brittle conversation. But if you put it on the website here, create your own group or your own discussion. There's groups there. If you're talking about ether, go to the ether theory and start a discussion group and discuss online. Let other people input. You won't be stuck in some place, because that's what's going to happen. I tell all these people, they go, well, it serves me. Yeah, it's going to serve you, but it may not serve even serve your own theory or your own model. Why? Because people are, when they are, again, in their small group, they become a groupthink in that little area, and no one from the outside can come in and say, hey, talking about fields a lot, but you're not telling us what they are, which is one of the things we're going to talk about today. So, coming this year, Stephen Bryant and Disrupting Physics, Rewriting the Rule of Physics by Stephen B Bryant. Super great talker. I mean, he could do TED Talks and stuff. I should talk to him about doing TED Talks for our group. But it's certainly really, he's certainly a very interesting person, and he has agreed to talk with us, come on and talk about his book. I think he's got another version of his book or another edition of his book coming out or whatever. He's saying he's waiting for something before he does that, but that's okay. We can wait, but that will be definitely this year. We're looking forward to him. He pops on here once in a while. So Steve, if you're there, hey, let's set that date up soon. Of course, coming in January, my graphics. I didn't change the graphic there, but it's coming in January. It takes a while to get these people and get them lined up. So he is still on board to be with us and talking with us, but Dr. Alexander Unsker is a very well-known author, and we'll be talking about the Higgs fake. Again, if you haven't read the Higgs fake, if you are a critical thinker and you like anything about particle physics and haven't read the Higgs fake, you're in real trouble, because you're going to find out how flawed that entire system is. So if your new model has the Higgs boson and quarks and all those things, W and Z particles, and whatever the other latest particles out there, you better read the Higgs fake, because it's going to show you a house of cards on the way they do their science. It's jaw-dropping. I mean, you should get it. It's a short book, really worth your read. So I would check that out. Coming also, and this one we do have a date. I got to remember, we're in February, second week maybe, is Nick of Time, your time guru, saving scientific souls in the nick of time. Hey, great marketing here. Nick is from Harvard, and he is, if you haven't checked out his YouTube channel, go to youtube.nickoftime.guru. And he has a lot of great videos. He hasn't put one up for months and months, but he's got lots of them. So, just like we watch, all of you people who are stuck because of COVID watching at home Netflix and watching some series, binge watching a series from 2012. Yeah, it doesn't matter if these videos were this year or this month or 2 years ago. He's got a lot of great videos. If you want to know all about time and special relativity, the mathematics behind it, etc., that he is a amazing mind, very bright guy. He's an octogenarian, but you would never know it. I mean, he's an amazing guy. Here are a couple of videos that came out this week. Proton Spin. Proton Spin is not one half. Half a spin. Think about what does it do? Spin halfway and stop. Well, for those who don't know, let's see. Oops. Where's my... Here we go. According to lore in mainstream physics, half spin is right here. It's not at the equator. Okay, there you go. Half spin. It's real sad. It's sadder than sad. So if you're a critical thinker coming to this channel going, I've thought about that same thing, that is a problem. Yeah, well, stick around, folks. That's what we're here for. Critical thinking. So another one just came out this morning is Csquared. Boy, there's a lot of interest in Csquared. Sorry for the pixelated picture here, but my father talks about Csquared. He goes into Quora. He likes answering questions for these people. He's up to over 400 subscribers. Got to be careful. He's going to past me someday here. Once our book comes out, I'm sure it's going to go up. But he talks about that. And of course, Csquared has talked a lot about in the NPA, which is now the CMPS. I remember discussion, one conference, and it was always held in the mathematics building at the University of Connecticut, and was between Peter Marquardt, who's still alive, amazing guy. I'm going to try to get him on. I'm going to find him. He has barely has a computer and all that. I'm going to try to get him on sometime. That guy is one of the most fascinating people to talk to on the planet. And he did a paper or papers, and they discuss quite at length with Bob Heaston, a person that passed away a while back now. But both of them talked about Csquared. Why is it everywhere? So very interesting discussion. So my father tackles that. And of course, remember, folks, to subscribe to all these people. The Fractal Woman, she's past me. She's got great videos on the physics of the universe, and she's one of those people like me that wants physical models. We're tired of mathematics only. And of course, the energy wave theory. Jeff Yee, haven't you got to him? He's over 2,000. Nice graphics, Jeff. Who made your logo? Pat myself on the back. That's sad. Well, the good thing about what I'm saying there is if you happen to have a website or a YouTube channel or whatever, I can help you out with it, graphics, whatever. I know I said, hey, do you got any logos and stuff? I help them out. So I'll help anybody out. I don't care if your theory is right, wrong, or whatever, but you can see that they're simulating. He's in the simulations down here. If you look down here, you can see actual physical models in Blender, which is basically a physics, it generates physical models as if it's real physics. So you want to check him out. Subscribe, folks, to these people. Remember, that's the way you support people today. Okay, you don't get their newsletter letter that's typed on a typewriter, sent you through the mail, and then call them up on the phone and say good job. No, we can do this publicly now. So Particle Guru, my father, want to check out his channel, and again, subscribe and like. Nick of Time, I did talk about him. He's got, I don't know how many videos. So it's quite a bit. I'm sure you can go there. We're not doing easily. I said, Nick says, well, again, I've done videos for a long time. So that people keep subscribing, because when you got good stuff, it doesn't matter. And of course, as Alexander Unsker says, keep working on your passion. One of the things is that I will say, and I've talked to Ivor Cat, for those who know perhaps who he is. I admire him and his work greatly. He's actually called me on the phone late last year, and just out of the blue, and we were talking about stuff. And he did say something. He said, Dave, there's something different between me and you, and that is, you support everybody's work, and there's just so many people wrong. I just can't do that. Well, let me make a statement about this, and I've made this before, and I'm going to pound it into people's head again. If you are wondering why people aren't reading your work, it's because if you have an attitude that I'm right and everybody else is wrong, then why would anybody want to read your work? Or why would anybody, how would you have people want to support your work if you don't read other people's work themselves? If we don't show an attitude of support for each other, then how in the heck? I've got so many dissonant people saying, well, we should send our stuff. Or I know one person last week had mentioned, and that's fine. But yeah, we want to send and have debates in universities. We don't even support each other's work. We don't take 2 minutes time to go to YouTube, create your, account, go in and support everybody working on things. And then you wonder why no one's listening to you. You getting this idea? So this whole idea, when Alexander Unsker, of course, he is a pretty big name in the world of dissonant science, probably one of the biggest out there, who really is going against mainstream, especially particle physics. And he's a doctoral, and he's a physicist, scientist, and more of now a science writer. If he's out there saying, when someone asked them, they were actually trying more to get their blessing. They have some theory. It's an ether theory. Most likely it's an ether theory. 90% of them are. And out there in the dissonant world. And, people are always wanting someone to come along and say, oh, your theory's right. I agree with your theory. And he doesn't do that. He says, no, just keep working on your passion. Who chooses who's right? Isn't me. It isn't you. It isn't even all the people. Well, it's closer to all the people because in the end, history will choose. So keep on working on it, on what you love, and keep on doing your model and all the math behind it, or all the physical, the graphics, the drawings, the model of it, the physicality of it. Just keep on doing it and support others, because you are a hypocrite if you are a person who says, all these people are wrong, why should I support them? And then you turn around and say, why isn't anybody listening to me? Okay, I know I pound on this, but folks, that's why we're here. Why do you think Greg and I do that constantly? The way I look at it, folks, is that people who are working on their own models and theories and ideas, it's really hard already. It's really hard to get out there and say, hey, I think relativity is wrong and this is a better model for it. Or I think the Big Bang's wrong. This is a better idea for that. Or even just criticizing mainstream stuff. And especially if you have your own ideas, dipoles and all kinds of things. You hear all these words. We're going to talk about these things today. And again, it's a passion that you have. Well, you want other people to listen. So get out there, continue to work, and let's support each other. I have a great admiration for every person out there. I have a great admiration for everybody watching this right now. I have a great admiration for anybody who is willing to stick up in their heads out and their necks out and say, hey, I think I have a better way to look at the universe, and here it is. But support each other, folks. Support each other. Okay, let's keep moving along here. Get to our slides today. I think we're going to be there. Yes, science, poetry versus physics reality. Now, I don't remember who it was. I don't know, it was Bob Gray or James Keane or somebody said the word science, poetry. And I told them on air, you can go back. So I'm going to steal this. It's really pretty much that. It's science, poetry versus physics reality. I mean, we hear a lot. That's what it looks like to me when I see people in the chat and they go, I think the universe is full of energy and it's this and it's, I can't even come up with them myself. But when I look at them and I see these phrases, it's a lot of words. It's a lot of words. And I'm thinking to myself, I'm tired of words. I've been around physics critical thinkers since in my early 30s. I'm now 61. So I've been around 30 years, great thinkers. And I hear lots and lots of words. And I'm tired. I said, well, what does that mean? Oh, no, it's just, I don't care what it means. I mean, what do you ask me that for? But here's my system, and it's got energy and dipoles and fields and charge. And I go, well, what's charge? Charge is a fundamental thing. What are you talking about? The problem is the general public is the same way where I'm at. They're just tired of it. And I see that. Oh, thank you, Franklin. Franklin says, that's James Keane, inventor of science poetry. Okay, James Keane, thank you so much. If you do nothing more in life, no, I'm just kidding, James. That's terrible, isn't it? It's like, oh my gosh. But yeah, thank you, James, for we could all be going down in flames here, lemmings off the edge of the dissident science world, but at least you have a word that a phrase that was really good. I love that word. So anyways, thank you, Franklin, for pointing that out. So yeah, okay, let's keep going forward here. So I got lots of slides here and we're going to start talking about them. So let me sort of set it up. We're going to break it down into two things, and I didn't announce this, but that's really good. So words, but it's more than words. It's also math. So we use words without thinking about the physicality behind them. We also use math if it were the language of the universe. So we're going to have both of those topics. I've got people in my green room that I know are going to be interested in talking about some of these things, and we certainly will do that. And I want anybody who is out there, if you want, you can talk with us live and come in the green room. We have 1, 2, 3, 4, 5, 6 people in there, 7, so we have room for 3 more people if you want to come on and say. And I will be looking at comments quite a bit, of course, today. And so let's start this off a little bit. Are most people talking science poetry today? You know, that's a big question, but that's something that, I mean, if I look at even the comments in the chat, and I've looked at them over the last bunch of, years, you see a lot of people talking a bunch of words. And then when you go and try to pin them down on those words, then all of a sudden you get, I don't know. But I see that as a huge problem. The only good thing I can say about that before I bring somebody up who can raise their hand, and if you're in the green room, put your camera on, raise your hand, please, or make something. I do want to keep this discussion wise because it's a lot more interesting, of course, if you can discuss live. Then, but I will be watching the chat as well. But I honestly think there's 2 things I would say about this. I say, yeah, most people talk science poetry. That is, they talk lots of words. They have systems, and the systems all their head. They're all logical, and that's all really great. But when you try to pin them down and say, okay, you're talking about energy and energy fields and all kinds of stuff. We're gonna go through some words, but I just want to. What I'm going to try to do is I'm going to try to keep people on topic here, because we are going to talk. I've got a bunch of words we're going to take a look at today that are also problematic, that people use constantly, and we don't talk about what they are. The good news, the other thing I was going to say is the good news on all of this is that the current models that people are truly pursuing quite a lot today, the more modern models, which I would say are in the last 5 years. We've had models going for quite a while back, or at least mathematical models, is that people are tired of it. If you look at almost everybody doing models today, they're going, I'm tired of saying the word magnetic field and not saying what it is. Like my father says, well, I'll get him on it. He has a good saying that. So that's my first question, everybody. So in the green room, I see people like there. We've got Bill Lucas, James Keene, Ian Cohen, Franklin Hugh, Bob Gray, Bob D. Hilster, of course, who's here, and he's been paid a lot of money to support everything I say. That's so not true, though. We're constantly arguing, which is good. So anyways, I'd like to really address this first question. And I really want to try to do this instead of just like a stream of consciousness. Let's guide it a little bit. Let's talk about, do you think that most people in dissident science are truly talking poetry and not physicality? Raising your hands. Anybody? Oh, good. There we go. Bob Gray, how are you? How are you?
Fine, thanks.
Well, it's good to see you, and thank you for coming on. So again,
Sure.
we're going to keep the question. And my contention is yes, most people. What do you think? Do you think most of the dissidents are talking really science poetry and not real physicality?
Yes, particularly if they do not use mathematics. And the reason for that, I look at mathematics as an extension of the natural languages. And it allows the natural languages to express more easily logical train of thought, which can then be transmitted to other people, and other people can then follow that logical train of thought. Without the mathematics, if you try to do physics without the mathematics, then I think it is a lot of science poetry. I don't think that you can do physics without the mathematics, and I don't think that you can do physics without the natural language and the modeling. I think you need both, but try to deny one or the other, and I don't think that can work. But I would like to ask you, how then would you define anything? For example, can you define love? Can you define an electron? Can you define a magnetic field? Can you, you can say, well, in my model, it's a bunch of particles doing this. And okay, but what are those particles made up of? Well, those are made up of another level of particles, and they're doing, well, what are those? And it's just an infinite regress. At some point, I would think you would have to say this, for example, an electron has these properties that we get from experimentation. Ask me what an electron actually really is, and you can't define it. I think, and if you don't like the electron level, okay, what the electron is made up of is a bunch of particles in somebody's model, but what are those particles made of? At some point, at some level, I think you just have to, you're not going to be able to get to a final foundation to define everything.
Yeah, well, I can. I'm gonna. This is great discussion because this is gonna bring out some. I have a little different takes on these. First of all, let's go backwards.
Super.
The infinite. The you can't define it. Well, the infinite levels. Many of the models today, our model, for instance, has that. Um, and when you look at it, if you subscribe to infinity, that is, there are no partless parts, there's always something below that that's going to be making it up. Are we going to be able to, how far are we going to, as human beings, go down below to find those things? Probably not that far. So it doesn't mean though that those don't exist. The other thing is the ultimate particle. I personally just can't buy that. A lot of people can't buy that, and that's why I think they subscribe to infinity. Because let's say you have a particle, I've said this many times, and it's going to make up the whole universe. Why does it then all of a sudden come together and do all these fantastical things to create this amazingly complex world? So you have that problem too. And the also thing about the mathematics is, again, I love mathematics. I got a bachelor's in it. Mathematics is great, but we're going to be talking about that later. But I mean, my father and I's model is based on particle movement classifications and no math at all, zero math. So it can be done, and I think mathematics is important for sure. But I would say that the new models out there, for instance, let's take Jeff Yee. Jeff Yee has $15,000 on the line for him doing his models. He's using Blender. Blender is a physics machine, and there's mathematics going on inside to simulate it, but the actual what's happening there, except for like the force of gravity or the force of Newtonian force of a body in motion hitting another body will collide and cause more motion. There really is no math in there. So I guess my question to you is, what can you say to a model like Jeff Yee's or my parents, my father and I's model? Ugh, Freud's all over the place here. That we don't have any mathematics at all, and that what we classify, for instance, as a magnetic field are simply particles going around. So whether it be in orbit or whether it be lots of particles going around molecules that we then claim is making magnetism, that's what magnetism is. It doesn't matter what level in the universe you're at. I mean, it's just a classification. So whether or not you have, lots of asteroids going around a star, or whether you have G1 particles going around in nucleons that create what we say are what we call magnetic fields, it doesn't matter what level you're on. You could be levels way down. You can have the same thing going on. So it's just a classification. So, I mean, what do you say to those like Jeff Yee or myself or even Glenn Borkert? Those are three models. Well, actually, five models that I mentioned before that really don't have mathematics. They're more of, the movement of particles. So what do you say there?
Well, I'd want to know how you would engineer with that model. I need to make an MRI scanner, a body scanner, medical scanner. Okay, what kind of current do I need? What kind of intensity of magnetic field do I need? What kind of blah, 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 to actually work with that model. I think you do need the mathematics. The conceptual idea behind the model, you may not need the calculus, and you may not need, tensors and et cetera, et cetera. The engineering, I think you do.
Yeah, sure. So what you're saying is engineering is very useful because what we want to do is take a model that may not have mathematics or it's conceptual, right? And then be able to project. For instance, in our book that we're coming out with, we've got a huge section in it in electrical engineering, and my dad has calculations with it. So, but I think maybe is what you could be saying is we could be more clear is what you're saying now is mathematics is great for the engineering or technical use of what a model may predict. So for instance, our model predicts what's going to happen between two parallel resistors in the particle model that my dad and I are working on, and we have a part in our book that talks about that. What's its predictions, and can you measure it? And we have actually a my dad bought a volt machine that goes to point what 7 digits. I think it's used in astronomy, but it's super accurate, so you can measure things that people weren't looking for. And yeah, there's mathematics for that. So I don't think we're in disagreement here. We're talking about different things. So when you made the broad sense of mathematics is something that is, you better show me the mathematics behind what you're doing. I'm not sure. Maybe that's not what you in the end we're meeting. I think it's more clear when you say the mathematics better be can be applied to your model to do useful things and do
Right.
calculations. Is that
But
right?
yes, but do you consider your book, you and your father's book, poetry?
Uh, no, because what we have are just we have literally most of uh, uh, it's images and classifications and movements of particles. In fact, our diagrams are what you should be able to look at our book and understand what's going on without any math or even words. You can just
Well,
look at
that's
the
why I
way
ask.
particles. Yeah.
That's why I ask if you consider it poetry. If you're saying, well, we don't have a lot of math, we don't have any math, we're not showing it, we're just showing. I'm sorry for the word just. We are
Oh, okay.
showing pictures. We're showing, how this goes, and we're describing it in natural language. Well,
Yeah.
is that poetry? I think,
No,
well,
no, no,
that'd
no.
be good poetry.
No, I agree with you. I think that's a really good point you're talking about, and that is when you have a model, even if it's not what the problem is. My contention is when people use science poetry, is they'll use a word that when you ask them the physicality behind it, they don't have an answer. If you look at what we have and we use the word G1 particle, we can tell you very clearly what that means in our model, what it's going to be made of, what its function is. Here's the calculations you can make with it in electronic circuits, which we do, even if we don't know the exact size or whatever it is. So
Well,
I think the difference is that people use words, and then when you ask them what that words mean, they can't go back to a physicality.
but then is it an operational definition? For example, an electron. I don't know what it is, but I know that I can make an electron beam. I can use it in scanning electron microscopes. I can, charge a pith ball and another pith ball and see how they separate from each other. I'm operationally defining what I mean by an electron. Or do you think that you have to go into a more sub-electron kind of model in order to claim that it has the physicality that you're talking about?
Oh, you have to definitely go below that. You have to go
So
around it.
it's
If
not
you
just an operational
No,
definition. My
no.
electron does this in this situation, curves in a magnetic field, and you know you're saying that's not sufficient. That operational experimentation is not sufficient
No,
to define an electron. I see.
right. And that's one of the things that bothers me, and that's one of the things that bothers my father and I constantly. Is, for instance, I mean, if you look at Coulombs Law, for instance, you have
Mm-hmm.
charges, and no
Mm-hmm.
one tells you what charges are. There's no force there. You have no idea. Well, we have a real mechanism below it. We say anything that curves in the universe is from a random gravitic field, whether or not it's something like would be the electron we call electron photon graviton, or whether it be one step below it. If electron, what we call an electron, is orbiting, then in our model, for instance, we'll say there's a field below that. It's a gravitic random field that's making it go. It's a different particle. It's got to be a different particle. And you can keep going and going and going. But what I'm saying is, yeah, I mean, you have to. And I think the idea is that I think people have been around in the distant world for so long. And I heard these things for decades. Fields, dipoles, magnetic fields. Oh, a charge and a moving charge in a field. And I'm thinking the answer isn't the charge or the moving charge. The answer is, what's your model for these things? And that's what happens. So in our model, for instance, we'll tell you, right or wrong. We're not saying we're right, but we have that. And I think one of the things our model we're trying to push out into the world is like, okay, folks, right or wrong, we're gonna have a physicality for every time you ask a question. We're gonna tell you what physically is there. So if you say, okay, you're saying that an electron bends, well, how come you have to tell me it bends? Well, yeah, we do. It's a gravitic field below it. It goes faster than the speed of light. Okay. Oh, then if those bend, well, there's a gravitic field below that. If there's, for instance, the orbits around atoms, we can tell you why that happens, what they do, why they stick together, why magnetic. You have to have an answer, right or wrong. And I think that's where you see today's models. That's the rebellion. If you look at the rebellion of the models of 5 years ago till today, and again, I had those 5. The difference is they are tired of writing down fields and writing equations down for fields. And as my father says, telling us how, like Newton. Newton was smart enough to say, don't ever accuse me of knowing what a gravity is. Okay? I can tell you how a body goes through it. And I can tell you, in my opinion, that the apple falling down from the tree and us orbiting bodies are under the same influence of gravity, but don't accuse me of what it is. And one of the things is today we're tired of that. I'm tired of not, a guy on the street, if you give them 2 models, one model's full of mathematics and it's got all these equations. Then you get another model like we have, for instance, which says, they're going to say, what's magnetic field? Well, anything that goes around in circles, particles that stay in a circle in an orbit. That's what magnetic fields. Oh, okay. What's light? Well, light's this. What's gravity? Gravity's this. I think it's the rebellion of the new model builders and dissidents that they are tired, mad as hell, and can't take it anymore. And I think what you're I don't see you as wholly disagreeing with that. But what I'm saying is, I think one of the problems, if you've not been around that idea, if you haven't been around those people, if you haven't been around myself and my father, or Jeff Yee, or Glenn Borkert, or Laurie Gardee, or Yonel Denou, if we all got in a room, we're not going to be talking about charge. None of us. We're going to look. If you can say charge, oh, you like magic, don't you? And where does that come from? Well, because no one's defining what it is. So you're right. You have to be able to do it. And it's shocking, I think, to people to realize there's models that can do it, right or wrong. Right or wrong. I mean, my friend said to me, gave us the title for a book, he's my best friend. He says, Dave, it doesn't matter. Right or wrong, you're throwing something out there that gives a physicality to everything. Right or wrong. Right or wrong. And I think that's where we need to do a paradigm shift. And I think that's what's happening. I don't think it's not a choice of anybody. Everybody here can object to that. Everybody can say, give me the equations over this any day. Well, guess what? That's not what's happening. The rebellion is real. People are doing that. So anyways, Bob, yeah, go ahead. One more before I bring somebody else up here.
I was just going to thank you for having me on. And I see Nick says that he has some comments. I'd really like to hear what he has to say.
Oh, no, I'm not going to let Nick on. No,
no, I don't blame you.
no. Nick, okay, absolutely. Nick Percival, you are there. Yes.
I'm here. I just am so casually dressed that I will point the camera the other way.
Well, actually, that's a better scene than most. Look at my scene. I'll take your scene.
Let me start off by giving some examples of science poetry.
Okay.
And then a qualifier. Dark energy, dark matter, and especially in the Big Bang Theory, we have inflation.
Right.
which according to the model, the Earth or the universe is expanding due to the Big Bang, and then suddenly the rate of increase increases by a factor of 10 to the 26th or greater.
Right.
And then after 10 to the minus 32nd seconds, an incredibly, unimaginably small amount of time, it stops. That's the only way they could get a uniform universe. So, like dark matter and dark energy, what they've done is say, hey, we have a model, but the empirical evidence doesn't support our model. So what we have to do is, it's like solving a math problem. How do I get the empirical evidence to match my theory? And they do it by creating dark fudge factors,
Yes.
which are those. Now, I wouldn't mind it if they say, hey, this dark matter, we have no clue whatsoever what this stands for. It's just a label that we are putting on the fact that there is a gap between the empirical evidence and our model. But they sort of say, hey, we've solved it. This is dark energy, and it doesn't have any properties because we can't see it at all. It's just a math gap. So I think Lee Smolin put it very well regarding math. He said there's nothing wrong with math. Math can be a useful tool.
Yes.
But the problem is when one starts using math and is unconstrained by having a physical model, you can go off into fantasy land, and that's what's been happening to a large degree. And I'll give one example that shows why math is not sort of the fundamental language, and that is in relativity. We have equations in the area of kinematics and describing space and time, or space-time. And the equations of relativity have matched the empirical data reasonably well for observations, but not for things like proper time, which are absolutes. So there are two sets of equations that mathematically look identical, Einstein's and Lorentz's, but they are at opposite ends of the spectrum in terms of physicality. Lorentz has a very definite physical model, but Einstein's is pure math, and that's where you get into trouble. And the problem now, we have a series of equations, and when those equations don't match the empirical evidence, one just uses a math problem to build an ever higher edifice of fantasy. So, that's my comment.
Well, no. I mean, I think that's really interesting, and especially you're talking about relativity. My whole foray and my entrance into the dissonant world was with Dr. Riccardo Carrazzani. He had his doctorate of physics from a university in Argentina, and what he found is exactly what you're talking about. When you look at the mathematics of special relativity, he found not only an error mathematically in going from special relativity to Lorentz supposedly, but he also found that mathematically, that is, when you set up frames, this is it took me 3 years of reading his math because he talked mostly in mathematics, but it's funny because he really was talking about physicality. He didn't believe, he's sort of like me, he didn't believe that there were magical things in the world. But when you looked at the relativity, you have frames, right? And if here's a person talking about math works in the right frame, which is GR is not stepping. Frames are a mathematical, artificial thing that we throw out into the universe. And then to say somehow that every moving thing has its own inertial frame, and that there is the mathematics between those two, then start making predictions that we then, in special relativity, take and say, boy, the math that we have, the frames which we artificially throw into the universe, and we put negative numbers on because there's no negative numbers in the universe, but we do that anyways. Then I throw a frame on a train and a frame on a guy off, next to a train. And then I start doing the mathematics between them. And I see the symbology gives me some kinds of relationships of being able to calculate. All of a sudden, when I throw the philosophy of, you can't go faster than the speed of light and all frames have the same physics, all of a sudden I get these bizarre mathematical conclusions that time dilates, mass increases, and what's the other one?
Length contraction.
Contraction. So, I mean, aren't those really in special relativity, those things? I mean, we're getting ahead on math, but that's okay. Aren't those things in special relativity truly vestiges of us getting caught in math and going down fantasy land?
Well, mostly since everyone has their own physical model that are contradictory with every other inertial observer. So that gives a hint that something's wrong.
Right. Right. Okay. So we're going to have you talk about that later anyways, because you're going to be coming on in February. And I really look forward to conversations and presentation. We're going to have, Nick's going to be doing a recording of a really good we can do that too. It's one of the things too, if you're wanting to present your ideas here, we don't have to do them live. This is done quite a bit today on internet. You can make your presentation, put it together, have it recorded, and we can watch it all together, and then the author can be there. So he will be doing that. He's putting together something like that. So let's move on. We got so much to talk about. So I'm going to go back to go back to this and go to the question. This is what I put down. We're not going to talk about this. We sort of talked this to death. But one of the things is I would say to people, be careful. It's dangerous to say, I don't care. I've got my theory. I use my words. And it's dangerous not only for science and teaching critical thinking to people, but it's also dangerous to your own work. Because what's going to happen is someone's going to come along, and I tell this all the time. Someone's going to come along, look at your work, listen to your words, and say, well, that's all nice, but you don't tell me what a field is. You don't tell me what a dipole is. You don't tell me what a magnetic field is. You don't tell me what electricity is. So, I mean, that's nice, and I think your system, and they're not going to pay attention. And then they may look at something that you have, like it, do better at it, and then put real physicality to it, and then what do you do? So be careful. It's very, very dangerous to say I don't care about the language I use. So, okay. Energy. Energy is one of those words I hear a lot. Since we've been doing these for a while, and I've been harping on that. I don't see it as much, but that's a word that people use. It's a useful word because we use energy to do calculations. We do, but energy itself is not a word. And what's really ironic to all of this, if you've seen my documentary Einstein Wrong, I talk about this in equals mc squared, the most famous physics equation on the planet. Everybody just think that's great. Mass, multiplied by the light squared, and you get energy. Well, what is it? What is that? And one of the things that I've noticed through the years, E equals mc squared, and people trying to explain it, is they'll use the equations. They'll use the equations that people have, and they'll explain it with equations, but they will not explain it in a physical reality. So what that really means is, unfortunately, the most famous equation in physics, in my opinion, is somewhat useless because it's not, without a model, you don't know what's going on. And if you look at it with today's models, most people who are in the newer models in the last 5 years are going to say, it's sort of like non-interesting. I'm not interested in E equals mc squared. What I'm interested in is how the universe works. What are these things we call light, gravity, electricity, magnetism? And, I don't care about energy. The word energy is just not something interesting to people with physical models. So I don't know if anybody in the green room wants to talk about the word energy at all. maybe not. We've beaten words to death before, but oh, okay. Franklin wants to talk about energy. All right, Franklin, welcome. Hey, Franklin, how are you? Welcome.
Good. So
Happy
as you're
day.
talking, so of course I went to the store knowledge of the universe, which is Wikipedia, and asked what a joule is, which is the measurement um, for
One,
energy.
well, one of the measurements for energy.
And
Yeah, I mean, it's got all kinds of energy has all kinds of units.
although now, if you look at that particular definition, it has to do with motion, accelerating something with a force of 1 Newton over 1 meter. Now, that's kind of how I see energy, is that it's strictly matter in motion. So if you have matter in motion, the more of it you have, the more energy you have. So I just wanted to throw that as a possible actual physical definition.
No, I think that's great. I think you are at least on the right track, Franklin, because you're trying to give a model for it. You're saying this is what it stands for. I will buy that way more than the idea that, energy is something. I look at more energy the way linguistically. Linguistically, we sort of use energy as people on the street. Oh, there's a lot, I've got a lot of energy, or there's energy in my gas tank to make my car go. It's more of a how do you get work out of something, how do you get movement out of something? That's usually what it means, right? There's energy coming into my house. So I agree with you. I think if we had something to say about energy and to saying that had something to do with movement, it says, here we go. Energy says, I don't care. Now that, but this is getting, I don't even know how to, that's pretty funny actually. Being like, I don't care. Well, I guess the way I would say Sandy is energy doesn't exist. It's a fantasy. So you can say fantasies can talk. So there you go. So energy doesn't care. But I do like your idea of movement. That I think is, I would say that's closer to it. Of course, if you're Borkert, movement is time. So, but I think that's an interesting point. Anybody else want to talk about energy? Is that all you had
I
there?
think it's also like Bob was
Okay.
saying, it's kind of an operational thing. I think it's okay in science to do those kind of operational things. So I can understand that you think that if you can't explain what charge is, that's poetry, in which case, yeah, everybody practically is doing science poetry. But that doesn't preclude you from doing useful work. So
Okay, I understand what you're saying. I will push back on that, like I did push back before. It's different to say science. Science poetry to me is words without physicality. And there's two things I would say. So to say that, for instance, labeling a particle a G1 particle is poetry, it's not. You're labeling something that's physical, right? The second thing is that
but wouldn't you need to find that? I mean, I'm perfectly fine with having particles, but I don't know if mainstream science has found your G1. So is that poetry? Or
no, because to me, what it is that if you can't explain the physicality, you've got to call it something. We can call the particle this, right? We're talking about this particle in our model that does these four things, okay? Now, we have to label it. We can call it Fred, all right? We can call it Fred. Now, that, yeah, there's a difference between, I think, labeling and science poetry, which what I would call science poetry. I think that what James would call science poetry. I think what Nick was calling science poetry are using words with having no idea what they are. For instance, you were saying dark matter, right?
Well, you need to bring in the experiments, for example. I think maybe that might be a distinguisher between science poetry and, I don't know, real science. So, like, we have experiments, people. I see we have Dr. Lucas here who work on accelerators, and they find like all these different particles. They find mesons and
Claim to find them.
electrons and all these other exotic things, and we can make beams out of them. So those are experiments. So what I'm wondering, I'm asking you is that you have G1, which is not any of these known particles, right? And so
Wait a minute. A G1 takes the place of a photon, electron, and a graviton. So You can call it electron if you want. If when it's going around the nucleus, you just call it electron. You can call it well, you can't call it a photon because a photon is not what we have. But again, it doesn't matter. Let's throw away our model. When you look at when you look at something, if you have a physical thing, you got to label it. That's different from saying I have charge and not. The other thing I wanted to say about charge is people say, and I've heard this over and over, charge is fine. We can use it because it works perfectly well. It doesn't. Charge doesn't work. You know where it fails miserably, charge? Charge fails miserably when we try to use it with a moving charged particle in a field. We don't know if it's the charge. We don't know it's the field. We don't know if the charged particles. It's a mess. So the idea that charge is a good model and that I'm perfectly happy with it. Well, for 400 years or almost 400 years, we have chased our tail trying to figure out where charge stops and a field begins and which causes which. Now, to me, when I listen to that, it's a mess. I'd rather say, oh, there's not charge. Things move together because there's a force that pushes them together. This is the force. And so I understand this argument that I've heard now several times, and again, this is my opinion, is that when people say charge is perfectly fine for me, I said, it ain't perfectly fine because it's been chasing our tail for about 400 years on that. But the other thing that you mentioned too, which I thought was interesting about language, was dark matter. And I thought you put that, I put that up before, and you're talking about dark matter, right? Here it is. I think mainstream do admit that dark means we don't know what the heck it is. The only thing I would say on that, I would add to that, Franklin, they don't admit that it could not exist, perhaps. They never say that. The reason is there's too many doctoral theses and Nobel Prizes waiting for them. They're not going. The difference between, I think, we dissidents and the mainstream on dark matter is, yeah, they don't know what it is. We have, Newton can explain without dark matter, in my opinion.
Well, they still think it's there, I guess, is your point, right? They still think
no.
It's
Yeah, they do. But what I'm saying is they don't. You never hear mainstream, Neil deGrasse Tyson saying, well, whoever what he's going to say, whoever finds dark matter is going to get a Nobel Prize. And believe me, someone's going to try to find it. Something's going to come out of that. You never hear Neil deGrasse Tyson saying, maybe it doesn't exist. Maybe we're just looking at this wrong. Maybe our calculations, maybe we can explain it in different ways. That's what we already did. We've already explained it with Newton. One of our guys in our group have already explained gravity, the stars at the edge of galaxies, as being perfectly predictable by Newton. So we don't need it. So I think you're absolutely right that that's science poetry, but they won't admit that. They would throw it out. So okay, I'm going to take you down, but thank you so much for that conversation. Anybody else want to talk about energy in the green room or make a comment there? All right. I'm going to go to this one, of course, we talk about a lot, which is, boy, I can't push all these things. Fields. I think that's more and more being realized that we also have to have a physicality for that. Magnetic fields, Lionel Deneu's been doing his experiments since 2008, trying to show magnetic fields are actually particles in rotation. Some people in ether theories will say that it's ether flowing around. We say it's the same particles, everything else, most of the stuff. So people are coming up with fields, gravitic fields. We have a couple fields, I think, in our model, but people are starting to put more into that, but you used to hear a lot about that. So I'm not going to talk, I think, about that, but I do want to, sort of put that up there so people. This is another one. Now, I know the electric universe people. First of all, I want to say I am a total supporter of the electric universe. I am always supportive of people who are thinking outside the mainstream, who are trying to get different models. But the field, electric field, charge, and electric, they'll say, well, that's electrons moving through. But what is really electric? About the universe? What is it about the universe that's more electric? What does electric mean? Now, again, several of the new models are looking into that. I know Laurie Gardee started to look at it, but I think I don't know if she abandoned it or whether that was Nell Deneau sort of even came a electrium or something like that that keeps ether waves confined within a wire, so that the ether waves within a wire is what electricity is. We say it's just G1 particles flowing. That's it. So people are trying to do something what electric is. So that's something. Let's take a look at some of the comments here. Dark matter is a misunderstanding of stars. They are all made of plasma, planets, or stuff, so they're the same. Well, I think again, what I would say, folks, go read Cameron Ribersol's paper. Again, people are assuming we can't explain it with Newton. If Newton can explain the velocity of stars at the edge of a galaxy, there is no controversy. There's no problems. We're just not applying Newtonian physics to a non-spherical gravitational field, folks. I don't know how many times I have to say that, but think about it. So it's not a misunderstanding of stars. It's a misapplication of Newton's gravity. We think we make Newton's gravity into a point, make everything in spheres, and we get bit by that. So let's see. Here's Jack talking about the words energy and force are not needed. The current broken BS math caused all the math problems. Broken symmetry. That's interesting. Maybe you can come on and talk about that a little bit, what he means by that. But again, electric needs to, in my opinion, needs to be defined as well. Charge, we've already talked about. So dipoles, I mean, we talk about that. I mean, I hear that a lot. And I think to myself, until someone gives me the physical meaning of it, not an equation, not equations that tell me, but the actual physicality of what a dipole is, then I'll be happy to listen. In our model, I don't know, my dad's listening probably. Dad, if you can say what a dipole is, do we even have, is that even a physicality possibility? Or are we talking about, because we don't know what magnetic fields are, that a dipole in fact wouldn't exist? Okay, I'm going to bring my dad up on that one. I think he's looked at dipoles in a physical model before. So you got to get your unmuted universe hacker. There he is. Get unmuted there. Hey, Dad.
Hey.
So, okay. Dipoles. Have you looked at that, and what a physical model? Is that a possibility at all in physicality, or is that just an impossibility physically?
I've never done a video or studied it to explain something like that with our model. So I really can't comment on what they think a dipole is. I mean, does an electron have two poles? Is that the point?
I don't know. I think somebody wants to get on here and describe that.
We talk about poles in our model in the sense that it defines the direction of the flow in a magnetic field.
Right.
Poles are not north and south. The N and S are just used to tell us which way the particles are going. Same thing with charge. We use plus and minus. We say with the electron has no charge, or the G1 particle has no charge, but the plus and minus is used to define the flow of the G1 particle. Flows the same way as the electron, from plus to minus.
Direction.
So, those are poles that I talk about all the time. But whether an electron is a dipole, or does a magnet have a dipole, maybe somebody can clarify that for me. But dipole per se is almost never used in our model, the term.
Yeah, and I think that's what I think we need to look into it just for curiosity's sake, because a dipole could be sort of a, how do you say what who was talking before? Bob Gray was talking about, maybe what's happening, or no, it was Nick. He was talking about mathematics, how mathematics systems will develop vestiges and things that aren't real in the physical world, and we'll get all hung up on them, like with relativity, for instance. Maybe dipoles are the result of people not having a model for magnetism and just looking at the mathematics of it, or the symbology of it.
There is one. I believe water is a electric dipole.
I don't know. Does somebody come on and explain what a dipole is?
Not
Now, I
correct.
don't know physically they can, but at least in a magnetic
So is the
sense.
water molecule a dipole? Because I'm digging this up without having researched it. So what I'm saying could be clearly wrong. But
I
that's
don't know. I
one
don't
thing
know.
that I remember.
Oh yeah, I mean, someone says, yeah, water is an electric dipole molecule, and it could be that, Dad, what people use for dipole is just different situations. It's
So
sort of like,
the polarity, and the polarity allows electron to flow, current to flow, uh, and it becomes a necessary part to help explain all the electrical phenomena we talk about. And, and that's okay, but then the question is, look at a molecule, two hydrogen, one oxygen stuck together some way. Uh, what part of that physically makes it a dipole?
yeah.
The
I mean,
oxygen is plus, the two hydrogens are generally labeled minus, or did it the other way around? Uh, those are ions. An ion is not a dipole, but water is. Uh, and how far that goes, I really don't know. But I have never used it in any of the videos I made or write or a book or whatever.
well, I think, Dad, it comes from people talking about magnetism and using the symbols of magnetism, not knowing what it is. And I think because of the symbols and the systems that people use, again, non-physical systems, but more I don't know, systems, just systems, that maybe the dipole has risen the same way as some artificial things have risen from special relativity. Yeah, you can call it that, but then when you, again, going back to science poetry, what I'm saying is I think dipole is a science poetic word. I just think it's referring, it could be referring to what in our model would be three very distinct things, but because they label pluses and minuses, that
I
then
I have a specific example that I've used in many videos, and that's what I explained in the video I released this morning. I use the phrase C squared to describe the speed of the G2 particle. I'm not trying to get into any details, but it confused a viewer, and so I responded to his statement, his question, and C squared in the way I was using it is poetry, because
right,
literally I'm not trying to say the G2 has a speed of 9 times 10 to the 16th meters per second. In fact, he called me down on it because my units are wrong. And so I go into the video, I use it all the time. And so I really had to explain my way out of the using the poetry.
right. Well, I think part of it, the
But
poetry
if you want
comes
to
because
understand why I
yeah,
was using it and I'm really trying to say, I'm going to get a plug for my video. Watch my video, S particle, not Quora, subtitle C square.
yeah. But no, that's true. I mean, what happens, Dad, when you get to a certain point and you don't have the the I think what it is, when you don't have the level below what you're talking about, yeah, you're just labeling it, right? That's what
Yeah,
you're
it's
doing.
just a
Yeah,
name
it's just a
for it,
name.
and it's not really that. When my estimate is, it's uh, 30,000 times less than C squared would imply. So that's my estimate. But then what do I say? I got to say this strange number all the time. So I
Yeah,
labeled it C squared, trying to give people the idea that the G2
right,
particle is moving very fast.
right.
So but it's poetry. It's not
Yeah.
technically correct.
So C square is poetry. Yep, because it is not technically correct. We don't know what the speed is. So, yep. See, there you go. Our whole book's poetry. All right, Dad. Thank you very much. Let's go on here. I'm going to move on. Let's talk about the mathematics because we've already talked about it. but I've got some slides on it, and I'm going to actually bring up some new things because we are 11:15, so it's a good time to switch from here. So is mathematic an impediment to models? I think we've actually talked a little bit about that, and we talked with Bob Gray brought the really good idea up that math is the technical side of us using models for doing calculations to predict things, right? If we want to build in a model, let's say, oh, you subscribe to Jeff Yee's model, and he has the neutrino, which is it's not the same as the physics neutrino. And we could then come up with the size and whatever, and it's really small. Could we make an microscope, like the electron microscope for his particle, what he calls the neutrino microscope? Yeah, the mathematics can help on that. But it does get in the way, in my opinion. It impedes what goes on with models because we get stuck on it. We get stuck on the math, and we forget that, okay, does this really have something behind it? The other thing is the real number system and no negatives in the universe. So I'm going to do a couple of slides here for those people who don't understand that. The real number system has real problems. So, math is an impediment. We talked about that. Here's something right away we can talk about is the sine wave. The sine wave, and somebody had mentioned here, and I think I talked with him maybe on the phone. I think that was Jack. Jack, I think we did talk on the phone. Let me see. Here we go. Jack has said, I've developed an entire math system that eliminates negatives, positives, imaginary numbers, and absolute values. I label it symmetry math. That is super interesting, Jack. Another person I'm going to show you a book of who does not something similar, but does something similar is Peter Erickson. And he talks about negative numbers specifically. But I mean, so Jack, I guess he's still working on things. I talked about him talking about it. Sometimes people are willing to talk about it. I don't think he said he's ready to, but regardless, let's take a look at a sine wave. So we put a sine wave, which has a timeline. On the opposite side of this zero would be negative numbers. Now, there's nothing in the unit. That's just a label. We literally took our real number system, 1, 2, 3, and we made decimals out of it. I don't know, again, 10 fingers, 10 toes. I don't know. It's a decimal system. And we put 1 on it. And for us to say that it's on the other side of this, what we call origin, or where we're measuring from, we're going to call it a negative number. And we'll put this little dash in front of it, like this A. Here you have A, and here you have minus A. These are just conventions. When we look at the universe, there isn't a negative sine wave anywhere in the universe. What we can say is if we were to push this line down to this max line and then called this the number of particles or that are moving, let's just say that, then down here we'll have 0 particles, and then we come up here, we have this many particles, and it comes back down again. That's the physics of it. But we don't have negative numbers in the physical world. That's an invention of ours. And that gets us into extreme problems. And if you don't believe that, well, take a look at The Nature of Negative Numbers by Peter Erickson. I would highly recommend it. This is a review of it. Again, Peter Erickson. I'll put this up here. I have it myself. There it is. And I got lots of stuff in it because I was writing, I think I wrote something on it. I don't remember. I think I did. Or wanted to interview him. But I will read this to you. In his book, The Nature of Negative Numbers, Peter Erickson argues that the real number system, although broadly accepted, is deficient mainly because of its ambiguities, which is true. In algebra, the plus symbol can be interpreted in 2 ways, as a measure of positive quantity and as the binary operation of addition. Likewise, the negative symbol is a measure of negative quantity and the binary operation of subtraction. Erickson tells us why such ambiguity is confusing. Consider the equation +6 + +3 = +9 on a real number line. Here, the second symbol means an addition to the two positive quantities by starting at the location +6 and moving 3 units in a positive direction to the right to the location +9. Likewise, the equation +6 minus +2 equals +4. The negation sign means move 2 units to the left to the location +4. However, the equation +6 minus a -3 equals +9. The negative values, 3 negates both the negative value 3 negates both the subtraction operation and the quantity itself, so that the equation changes to +6 plus +3 equals +9. Generations of students were taught that 2 negatives make a positive. Such sleight of hand is ambiguous. Keep going here. Ericsson will have none of this. In a system he calls the variable number system, positive and negative quantities are divorced from each other. The author states it is impossible to combine negative and positive variable numbers with each other. In this system, operations on positive and negatives are not allowed. Ericsson defines analogous operations to real addition and subtraction with the different operator symbols of the and sign indicates addition and the tilde indicates subtraction, while multiplication and division operators are unchanged. Within the system, he can conclude that the square root operation of -1 is -1, is the true making imaginary numbers less magical and filling in the blank on the covers on his book's cover. If you see that right here, the square root of 1 is equal to, in the variable number system, -1. The majority of this book works to reconcile and integrate the variable number system with a variety of mathematical topics, including the nature of zero, rationals, which are fractionals, absolute values, Cartesian and polar coordinates, and logarithms. The material is complex, but the language is precise and the reasoning convincing. This is a review of his book. Readers must be well versed in algebra, trigonometry, analytical geometry, number theory, and elementary calculus. And adequate knowledge of these concepts is assumed in order to understand Ericsson's presentation. This is the last part here. Mathematicians may deliberate the integrity and acceptability of Ericsson's system. For example, in the discussion of relative placement of 0 on the number line, Ericsson notes that the existence of 3 temperature scales, Kelvin, Celsius, and Fahrenheit. He argues that only Kelvin's scale treats 0 as absolute and believes that that fact renders both Celsius and Fahrenheit absolute and that it should replace them. Neither this change nor widespread use of variable numbers is going to happen anytime soon. The author's nonconformist attitude toward accepted number theory allied with a lucid narrative make this book an interesting and thought-provoking read for mathematicians and scientists. That's really pretty amazing. If you haven't read or encountered Peter Ericsson, you should. And the reason is because, like Jack was saying, that he's developed an entire math system that eliminates positives and negatives. I don't know if Jack has read this book. Maybe he has. I'm not here to judge or say anything on either count. But look, here's a really interesting, this whole idea of Kelvin, Celsius, and Fahrenheit. Kelvin, Celsius, and Fahrenheit are just like arbitrary, right? I mean, there's movement of temperature is Brownian motion, right? So we're really trying to measure Brownian motion, and that are molecules. And it's, that's what we're trying. That's a very specific thing we're looking at. We're looking at the world of the atomic level, and the atomic level, molecular level, we're looking at a certain type of kinetic energy that is there. It's not the only thing. I mean, absolute zero does not mean the universe has stopped moving. But it may be the case that absolute zero is impossible. But regardless, the idea that he's putting forth here is that, give you a physical example, Celsius and Fahrenheit, they shouldn't really exist. We should really have a one scale, because there's no negative temperature, -32. I mean, we have to What is that? It's just a sliding scale. So why don't we have Kelvin? So I thought that was extremely interesting. I also thought it was very interesting his mentioning of I thought this was truly great. His example of negative numbers, and I think that's something that Jack was talking about too. So anybody waving their hands? Okay, I know my dad's all over this. So let's see, positive or negative is just a state of light matter. I'm not sure. Are we talking science poetry here? All right, I'll bring my dad up. Anybody else waving? We'll have someone talk. If you wave into the camera, I will bring you up. So go ahead, Dad. Go ahead. Are you mute? You're on mute. You're on mute. Hello.
I unmute myself because I didn't want to burp while you were talking, and I wasn't on mine.
Okay, so you wanted to talk about the negative, positive. Go ahead.
Yeah, well, one of the best applications of the sine wave that has plus and minus, positive half cycle, negative half cycle, is AC voltage or current. And if you really look at the physical thing that's happening, to say it in terms of the standard terms, there's an EMF force that pushes the electron in a clockwise direction, and then in the next half cycle, it pushes it in a counterclockwise direction. So in that case, the sine wave is really direction, not value. The problem is then people take the negative symbol as if it were a negative value, when in fact it is just a matter of direction. Maybe vector terminology would be a better application, but very often you can look at the negative. I did a lot of explanations on IV curves for diodes and transistors, and they have a plus current and a minus current. Well, it isn't a matter of the fact that the current is negative going through a forward bias diode, and it's blocked because it's going through negative. It's attempting to go one direction in one when it passes through, and it attempts to go the other direction. It's not a positive and negative current. It's direction. Just
Right.
fine.
Now, another question for you, Dad, since I'm not an electrical engineer, although I'm an electrician. That's an inside joke, folks. But basically, I also noticed that in equations, don't they use the square root of -1 in electrical engineering?
Yeah, that's that's just a cheap way to get around using I. We use J instead. J is the square root of -1. Whether you call it I or J, it's the same problem. But what they're trying to do is use it as a coordinate system, and in order to do complex algebra, and it works. All this stuff in a sense works. Even with the bad math, you can get what appears to be the right answer. But when you don't have the math really representing what's going on, you get people thinking that that's the way it is. And then you start building equation on top of equation with these assumptions that it's representing something physical when you've lost it already. And
right.
But J and I, whether it doesn't matter, they're both the square root of -1 mathematically.
Right. Well, then in the end, what's happening though in the electrical engineering field is that the square root of -1, whether it's I or J, when J this case, is just doing calculations that are on a coordinate system. And if you would move the coordinate system to not have negatives, would that go away?
Well, you would think so. If we could all work in the first quadrant, it would be a lot better. But you have to set the center of your system in the middle of the coordinate system, keeping all dimensions positive, and then only explaining where it is in terms of direction. And
Okay. Oh, that's really weird. So, okay, so I get you. So if you have a radar or something and you put the point in the middle, then eventually, I guess, I don't know. Okay.
It's unfortunate, and it's unfortunate that mathematically it seems to work, and you can use the equations and go happily on designing circuits, and yet you've gotten away from the physics. So when you're into the physics per se, we ought to be cleaning that up and not carrying it with us. However, if I were to go design a circuit today, I might just plop right back into it and use those equations just the way I was taught, because it works.
Right. Yep. In the end, what you're trying to do is calculate for a practical purpose, right?
Correct.
Right. I mean, but it
ought to be physics and equations. You look at an equation, you should be able to understand the physics by looking at it. You start merging it together, and I explained that in my video today. You merge it together and play a little tricky game with it, you lost the physics.
Yeah. And you did all electrical engineering for 40 years without ever talking about holes moving backwards for current, right?
Well, yeah, you did it. You did it in college, but no, you don't do that. You look at specifications. You've got charts and you got rules of thumb that you can use, and they're all good. And every area of electrical engineering, whether you're doing a high frequency or voice band frequency, they all have their special rules, if you will, that work.
Right. Okay. Alrighty. Thank you much. Now we're going to sort of open it up to discussion here. Again, we're trying to discuss the language of physics and also the mathematics of physics. So interested in anybody who wants to speak on it or give their thoughts about it. We have a half an hour left. So I'd love to hear some people here about, okay. Oh, there's Ian. How are you, Ian?
Very well, thank you, David. I was going to come in earlier with regard to a point which might be appropriate now. First of all, I don't have any major problem with negative numbers or imaginary numbers. I think as your father said there, it works. I mean, and it can be looked at in various ways. But my objection to the poetry of science would be in this respect, a slightly different respect from the one we were talking about earlier. In poetry, there exists something that doesn't exist in prose, and I maintain shouldn't exist in mathematics, and that is poetic license. The poet can actually produce some verse which isn't grammatical or isn't factual or even is illogical, contradicts something else he said. And the reason one does that is for the beauty of the verse. So one departs from truth in order to establish something which is sort of congruent, and that is acceptable in poetry. Now, it's not acceptable in prose, and I maintain it shouldn't be acceptable in science, but it is acceptable in modern science, because I think more and more we hear, the theory of relativity or something is beautiful and it works very well. And, there are all these illogicalities and paradoxes, but forget about those because it works very well. So they're invoking a poetic license. And that is what I object to. It should really be, more geared to factual and logical thinking, as I think actually the comments were made in that regard as well. I just reminded of the character in Moliere's play, who was interested in prose, but then he was delighted to hear that he'd been speaking it all his life. So, indeed, mathematics has its own beauty. Bertrand Russell said that mathematics possesses not only truth, but beauty too. A beauty cold and austere like that of sculpture. Those were his words. So mathematics has its internal beauty. We don't need to, invoke another sort of beauty in applying it to physics because we like what it says, or it's appealing to fellow scientists or to the public or to the media, because that is actually what is happening.
Yeah, yeah. I think one of the things, especially if you look at a word like energy, I mean, that word has been really co-opted. I think the physicists do get into trouble. The theoreticians get into trouble because they do want to do poetry, and worse. And I think part of that, I don't know what you think, but maybe you'd agree. I think a lot of the pros that you see about science, who are science writers, and they try to use the beauty of human language, and then at the sacrificing the logical consistency, the consubstantiality, as which is the logical consistency of their words, they'll sacrifice that to get an elicited emotion, right? You'll hear, the dark energy. I mean, it's like, the Dark Knight. It comes with a lot of baggage with it, whereas it may, like the Big Bang. I mean, the idea of the Big Bang was a derogatory, as we all know. We've heard it 1,000 times. But it caught on. Einstein, light bends gravity. These are simple concepts that can capture people's imagination. But what happens is, I think those words become more powerful, and the physicality behind them gets completely lost until you listen. I don't know if you've seen it. If you go to Alexander Unziker's interview with David somebody's, who was the guy who won the Nobel Prize for reducing the 19 or 27 free variables down to a couple. He has a conversation with him. It's very, very it's Unziker's most famous conversation. And when you listen to this guy, it's pure poetry. There's very little physics going on. And the moment that Alexander Unziker throws this reality of science in there, and says, wait a minute, you could see this guy go off his poetry riffing and get frustrated and more frustrated. Like, what are you doing? They literally talk, I guess what it is people who consider themselves non-intellectuals, and people who use a lot of terminology that particle physics uses, for instance. People will look at, well, you got to know their terminology. The public thinks that they're talking about things that are real. But if you use your critical mind and really listen to their words, you find out that it is within a system that's built on a system, and that the physicality has almost left the building.
Yes, and I was thinking of some sort of parallel with public relations and media exposition. I think perhaps you were hinting at something which is tangential to that. The journalist is trained to operate in a particular way, and to bring information to the public in certain ways, so that they will be entertained, their minds will be captivated, and so on and so forth. And in a way, and unfortunately we have to concede this, that the scientists in the mainstream are doing the same. They're not only maybe promoting themselves, but they've been trained to express things in a certain way which will gel with others, and will gel with the media, and will gel with the populace, and dark energy and Big Bang, as you say, all these terms, they're being bandied around, and it's a poetry, but it's a poetry in the bad sense, because it's departing from logic and from fact.
Right. And I think, the biggest one, I think in that, and the most criticized theory amongst critical thinkers is relativity. Because if you look at it, it's interesting. I don't remember who said it, but I read it in an article way back, 20, 30, 40 years ago. I read an article about how at the time between 1850 and 1920, that things that we thought were solid ground were thrown out. Freud came along and blew apart the way, our minds work and the way things motivate people and emotions. Einstein came along and blew away our solid ground of time and mass and gravity and light. And at that point, relativity, I think, gave people this license to all of a sudden talk poetically, like time, it's flexible, it's relative, everything's, it really introduced Einstein himself, I think, was one of the great injections of poetry, using poetry into science, because the physicality, he never talked about the physicality. He never did. He never talked about the physicality of space time. He never talked about the physicality of what light was really, except for the photon. And he even introduced an idea that it caused more problems, right? The particle wave problem. So I think relativity was one of those ideas that really put through poetry right into physics and allowed everybody just start talking about everything. And I think relativity is the king of poetry. In fact, if you throw relativity and Einstein in your article, it gets picked up. One of the things about that is it gets picked up. So that in itself is what you and I were sort of talking about. It's really sensationalism, tickling somebody's brain. Neil deGrasse Tyson isn't good because he's a good critical thinker. He's a horrific critical thinker. The one moment on YouTube where he was confronted by someone saying, "Will relativity be wrong?" Instead of saying, yes, all theories are going to be wrong, they're not right. All theories are theories. They're going to be less wrong, perhaps, than the ones before. His response was laughter. It's been proven a million times, we'll never go back. Wow, why is that? Because his job is to go into an audience and tickle their brains by making some, thought experiment or some thing in there that will make their brain think of a connection they haven't thought of before. The last thing he's interested in is logic behind it. And that's why relativity is so, I think, taken down so quickly. If you sit back and with a logical brain, throw away all the poetry, right? And you really start thinking about it. I think the average critical thinker who looks at relativity for any amount with any true introspection of logic in a matter of a very short amount of time, you start to see it fall apart before your eyes. Yet it's poetry that sells. It's like you were saying, the science writers work at using flowery language, at using the language that they see other writers use that will pick up likes, it will pick up search engines, it'll pick up, those buzzwords. They're not interested if any of that really makes any physical sense. So, okay, I have another person who wants to talk. Thank you so much, Amy. We'll bring up Bill Lucas. You are on mute, so let's unmute you before you start talking there. All righty. We're still on mute. There you go. Hello. Happy New Year to you, Bill.
Oh, thank you. We were talking a little bit about Einstein's relativity theory, and a lot of people don't know that relativity theory was first published by Henri Poincaré 1 year before Einstein did. And he was in the process of developing what is called meta theory. It's a branch of natural philosophy, and the theorems in meta theory apply to all theories in natural philosophy. And what he showed was that special and general relativity theory were both false theories because they involve assumptions that are known to be false, and so logic would disprove them that way. And also, one of the theorems of meta theory was that no two fundamental theories can use the same fundamental constant. Well, the speed of light is a fundamental constant of electrodynamics. And so no other theory can use that. And if it does, that theory can't be fundamental. It's just an approximation to a correct theory. And the correct theory would be the one that uses that fundamental constant. So in the work that I've done, for instance, I've taken the empirical equations. There are 8 empirical equations of electrodynamics. We call them Maxwell's equations, but it's not the version of Maxwell's equations that are in the textbook today. We only have 4 of those 8 equations. Now, there are 8 unknowns and 8 equations, and according to the laws of mathematics, you should use all 8 equations to solve for the 8 unknowns. But after Maxwell died, Oliver Heaviside, who took over, he said, well, I don't want to do that. I just want to use electrodynamics. Just use 4 equations of electrodynamics. And when he did that, electrodynamics was incomplete. And when people like myself have solved all 8 of the equations, all the results that we give credit to for special and general relativity come out of electrodynamics, those 8 equations. And so if you use logic, you can show which theories are fundamental and which are not. And and of course, a lot of theories were not fundamental, but for instance, the general theory of relativity for doing gravity also uses C, and you can derive the force of gravity from electrodynamics alone by taking measuring the force between the vibrating multipoles, like dipoles, in elementary particles and atoms and that sort of thing. And when you do that, you get a better version of gravity than any previous version ever derived. You don't need to invent dark matter and dark energy, because the Einstein's general theory of relativity and Newton's universal law of gravitation, they do not explain properly the data for gravity that we have measured in our solar system by Pioneer 10 and 11, and they do not describe the velocity of the outer spiral arms of spiral galaxies that we have measured astronomically. So, but the electrodynamic version does predict all of that correctly. And so it doesn't require 2 theories, it's just 1 theory. And that's what the role of logic is in science. And if you look at the scientific methods that have been used in natural philosophy, you started out with the axiomatic theory, which is just pure logic and observation. But then after a while, people realized that wasn't good enough. And believe it or not, my family, the Lucas family, and in particular, Henry Lucas, is the one that set up the Lucasian philosophy professor at Cambridge University. And the second person to receive that was Isaac Newton. And so you see how people have been involved in that, but the role of logic is not being followed because it falsifies most theories. And it turns out that in the work that I've been doing, it looks like slowly we're replacing all of these other theories with just an improved version of electrodynamics. And that is very satisfying in the sense that each of those theories is better than the theory it's replacing, but it produces very similar results.
Right.
And I think that's the way it is with all of our ideas in science. We see something wrong with one theory and we make another theory, but if we don't use the proper role of logic, those theories will also be eventually disproven because they're based on the wrong ideas and the wrong assumptions. And,
right.
So anyway, that's one of my comments.
No, I think that's, I mean, what I see you talking about is very much like what Borger talks about consupponability. Consupponability is just a law that says your own internal logic better be consistent, right? And it's not consistent if you have something that you can describe somebody else's model in a more fundamental way. you're going to win out. That is, what you're saying, that is, that theory as being a fundamental theory is really more of a system that someone built over here in a smaller area that may work in this area, but overall, you can describe it in a more fundamental way. Therefore, that's a more fundamental theory. And then also, like relativity, you have the problems of things, how do you say, laws or contradictory logic within that theory, and that falls apart. So, all right. Well, thank you very much, Bill, for your comments. Bill is one of the Lifetime Achievement Award winners from the CMPS, and deservedly so. He's an absolutely brilliant mind. If you haven't seen his book, I think I got it right here. Yeah, the Universal Force Volume 1. I'm sure he has more, and they've been updated, so I will just let you know right away. And oh, there's another one. I got two of them there, so I'm sure that they're different volumes. But again, the idea is that our new models should be describing what other people have described either as right or wrong. So I think that's very interesting. We have 10 minutes left. If people in the green room are waving or want to make a comment, I see people there. Oh, I see some new people there. Harry Ricker, hello to you. James Keen, who's been quiet today. Bob Gray's also here. Again, if you haven't come on and want to talk to us, you can, of course, by going to this address. The way this works is this address, which is TI6SHG46BV. That's not easy to remember, and especially since that changes every week. So what we do is we make this what's called subdomain, and it will get you to this URL, and either on a phone, a tablet, or a computer like a PC or a Macintosh, you will be able to join in. You just need to have a video, and you don't have to come on video if you don't want, and a microphone. It's good to have ear plugs, but of course today and age, even our octogenarian folks are out there learning how to Zoom and everything. But let's see. Again, I will say, if you want to make a comment, let's see here. Lucas, there you go. Lucas looks tired, but speaks like a man in his 50s. He's pretty good and energetic. I would tell you that. He is no slouch. And don't try to get into a logic game with him, especially if you're dealing with force equations. I don't even try, and I've got a Bachelor of Science in Advanced Calculus, so just a brilliant guy, brilliant thinker. So if you haven't gotten his book, take a look, especially his the meta laws about the way theories should work and models should work. So yeah, there's a person, Karnarev, developed equations shows electrons do not spin around. We've got a lot of comments here. Let's see, it took 10 years. Okay, yes. Work direction is so Jack, who has developed his mathematical theory. I guess I talked with Jack. I don't think he has his work in a link. I asked him the same thing because he's come up with a new mathematical system. That's always interesting to me because I'm a mathematician. I love math. So he's making a comment. It took 10 years translating Karnarev work from Russian to English. Karnarev was one of the brothers I've studied. So say hello. Also hello to Roger Anderton, who's here. I believe he's got some videos out there as well. So if you checked out Roger Anderton, he's got some YouTube videos. And let's see, anything else here? Okay. Well, we've got 8 minutes left, and what do we do? Well, I do want to remind you, of course, of our website and our group. It is really important for everybody to support that. If you are coming every week and aren't at least trying to, if you can, donate monthly, a small amount, $5, $10 monthly, or yearly, $35, $50 a month, it's not greatly appreciated. It's needed. It's vital. It's vital to this group. It's vital to everything we do. And please become a paying member. You can go to our websites if you haven't. So I know there are other people here. Oh, I see Pyro's here too. Hello. And so you can go to our website. Where are they here? on my links. Well, you can go to our YouTube channels, but if you go to naturalphilosophy.org, here it is. There you go, naturalphilosophy.org. You can sign up, join in the fun, and of course, join in the conversations that we're having here. It's really important that we keep our community going, support each other. If you are a person that wants to talk about something or about a topic, you absolutely can do that. You can do it in one of two ways. You can prepare slides and talk about them live with us, or you can prepare yourself in a video recording and also be live, but we do require you to be live. We will be starting out by the end of this month, starting our transition and get into doing this year a virtual conference. That seems to be all pretty much unanimous from our last week. If you haven't gone and watched about our plans for the future of this year, take a look at last week's video. We talk a lot about what we're going to be doing, and one of them is going to be a conference. If it's a virtual conference, where do we hold it? Because every year we have in our conference proceedings held at a university. Maybe we can do that. I don't know. Any suggestions on that? That would be interesting. We can probably do that in some way. I don't know what that would be, but maybe have it based somewhere. Maybe we could even still have it in a local place and do it where people aren't having to pay any money. Maybe in a house we could do that and have actual people there. So then we could call it a place on the planet. I don't want to get into weird things like having it on a fictitious planet, our conference, but we certainly are going to want to do that, and we want to have papers. So what I would say to you is, if you have some ideas to write a paper about, we can help you with that. We do have a system called overleaf.org, which is I don't even know if it's .com, but we do have all of our papers that go on into that. It's using the LaTeX system. We put a template up for you, and you can put in everything. You don't have to format anything except for, of course, your equations if you have equations, and that then gets put all into a book, and that gets sent out. So I think what we're going to be doing is planning to have this later in the year, not during summer. We're usually doing it summer because people are off, etc. But and we'll be talking about whether or not we have that conference in the evenings and maybe on the weekend, which may be a little bit more wise. Maybe we'll make it 3 hours for a week, and then come into a Saturday, Sunday, and do a more solid time. But all of those people out there who are thinking in their heads about writing a formal paper to be included in our proceedings, please do so. You can contact us, but I plan to announce some organizational meetings for the conference, and we'll try to make it at a time where we can get people from at least Europe and the United States, which means we should do it more in the morning time. So we can do that and have presentations at that time. I really do think that maybe the best way to do these presentations would be to have them recorded and then have a person present those. That way we can get people on a schedule, because one of the problems, of course, is people, when they do live talks, is I have 173 slides, and if I take one of them out, the entire idea or theory or thought will blow up and no one will understand it, which of course we know that's not true, but maybe I'll do it that way. So anybody have any more closing thoughts before we go on mathematics or the science poetry? We have 2 minutes left. Anybody waving their hand in the green room? I don't see anybody specifically. So let's do a couple things before we go out. Take a look at our trailer for our group and what we're all about for those who are new to us. So, as even Dr. Lucas, our Lifetime Recipient Award, says and talks about the words natural philosophy, that's what we are. We're a group of natural philosophy, and we are that because we want to be able to talk about the universe critically and be able to sort of get back to things that I think we've gotten away in our world of science, poetry, fluffy words, catchphrases, how do you say, gimmick equations like equals some MC squared, in some sense, is something that has become bigger than the physics behind it. No one seems to be cares about the physics. They just get this idea that, hey, mass is energy, things like that. We got to get away from that. We got to start really trying to get models of the universe, because we're stuck, folks. We're really stuck. So, remember what I say: stay critical, stay thinking. I am David D. Hilster, your science therapist, trying to get you to the promised land of becoming a critical thinker. Ciao for now.